Hey guys, this is Zaidi, and today I will be talking about topic 1.8, which is the topic of the squeeze theorem. And this theorem is actually very not complex, let's just say that. So it's very easy when you actually get to used to it, and this is the perfect way to start and making a basic question and starting from an easy way and then going to the hardest of your ability. So let's start with this, and this one is talking about limits x approaching to 0, x sine of 1 of x, and this is basically now they're including more trigonometric functions, so that's pretty cool. And now they're actually including x to solve. So now this is not substitution. Squeeze theorem is not based on substitution. You have to find both ways, you have to find both ways of the answers and then try solving it, but it'll be more easier to understand when I actually do it and then show you what I mean by both ways. So now the first thing to do with this problem is so now the thing you should really understand in every equation or every kind of trigonometric function is that -1 is less than equal to sine less than equal to 1. This is very important because some people don't actually know that this is what it is, you know. And you know, what's it called? Sorry, it should be sine x, my bad. So -1 less than equal to sine x and less than equal to 1. So most people should know this because if you don't, then now you know. But same goes with cosine. Same goes with the sine. Same goes with sine if it's like 1 over x or 1 over half, whatever. Okay. Or anything that includes with x, like x squared, 1 over x squared, whatever. So same, it includes with cosine and sine x, or cos x or sine x. Okay. So now we're gonna have to replace -1 into x because we have x right here. Now generally -1 and 1 basically means x, which is limits of x, and then sine 1 over x. And 1 over x would be basically beside, the trigonometric function. So now let's start solving it like actually this time. So then this would be -x less than equal to sine 1 over x, and then less than equal to x. Okay, now we just replace that into the equation is interpreting as. Now the next step is to solve both ways. Solve for -x and solve for x. So you see what I mean by both ways now? Alright, so you will do lim x approaching 0, -x, which equals to 0. So in this problem, it is equal to 0 because you have to replace 0 to here. So when you do 0 to here, it basically just equals to 0. This is where the substitution happens. Alright. So if this was 2, then this would be -2 and then it goes to -2. Alright. Okay. So limits. Now the next one we're gonna talk about is positive x. We did -x, now we're doing positive x, alright? Positive x equals to 0 because when you replace 0 right here, it equals 0. Even if it's negative, it does not matter, it's still 0. Alright. Now these two are both the same answer or equal. Now that's good because that's where basically the squeeze theorem happens. This is where the squeeze theorem happens. That means that we're not done yet. This is not the answer yet. It's not just 0. It's not this. It's not just like this. You have to make an actual equation or actual problem of an answer in order to solve. So then the last step is to include everything that you just did as like a summary. So x equal to 0, and then you have x sine of 1 over x equal to 0. And now this is your actual answer. And this is where the squeeze theorem happens. And that's how you solve the answer. Now, there are more, it's not always 0 for these kind of equations, mostly like 2 or 3. They mostly have like a word problem sometimes that will like give you what to do. So it's pretty cool like that. And yeah, this is how you solve squeeze theorems.